Hi 13, I'm just making a quick video to do some extra practice on integration by substitution. One of these involves changing the bounds on a definite integration. It's very important that you're able to know what to do in that case. So you can either watch this video to get the extra help with how to do these questions. Otherwise, do make sure that you're looking at this example on Dr. Frost so you know exactly what to do if you've got bounds on your integral. Okay, they have to change as well. But if you want to sit through this video, then you can watch me go through it as well. Okay, so first of all, I want to integrate 2 sine 2x over 1 plus cos x dx, and that's using the given substitution of u equals 1 plus cos x. So we're going to do all of the same steps we did before, except because of the sine 2x, there's a big old hint there as to how that's going to work out when you do your integral. So let's write out our substitution first. U is 1 plus cos x. I want to differentiate that first of all. Differentiating is going to give me minus sine x from the cos x. And then solving for dx is going to give me du equals over minus sine x equals dx. There we go. Right, 1 plus cos x, that's something I can write in terms of u. Dx is something I can write in terms of u. This sine 2x, though, is going to cause us a bit of a problem. So it's probably going to be worth us writing down what sine 2x is equal to using an identity. So sine 2x, that is 2 sine x cos x. Okay, so what I'm going to do is I'm going to write that in my integral instead and then see what happens in terms of cancelling and writing in terms of u. So here's my integral, star. I'm going to rewrite it again, so which is 2 times 2 sine x cos x. That's according to the bottom line down there. Over 1 plus cos x. And then dx we've written as du over minus sine x. Okay, so by rewriting sine 2x in its form as 2 sine x cos x, we're now able to properly cancel out this sine x with the sine x that's underneath down here. Okay, I couldn't do that before because the top was going to have sine 2x and the bottom was going to have sine of 1x, which can't cancel out. So now we can. And now everything else I can write in terms of u. So I'm going to do that now. So this is 4, which I'm going to write at the front, 2 times 2. Cos x I can write as u minus 1 based on this expression over here. And on the bottom you've got u. And then you've also got du over minus 1, which is the same as minus du. Like that. Okay, I'm now going to distribute the minus onto this numerator and make the expression negative, and that saves me having multiple minus signs. So the next step is going to write 4 integrate 1 minus u over u du. Okay, now we're in a better position and we just need to integrate the u's. Everything's in terms of u. Now, it doesn't look as if there's a method for integrating this quotient here because the numerator for a start isn't the derivative of the bottom, so it doesn't look like an ln. But the trick to use for this is to notice a split numerator over a single denominator. And if that's going to happen, then the best thing to do is to split this into separate fractions. So actually we're going to integrate 1 over u minus u over u du. And that's going to help us because now we can write that as 4 times the integral of 1 over u minus 1, both of which can be integrated separately using the power rule. Apart from the first one, because it's 1 over u. So this is going to be 4 times 1 over u integrates to ln of u, minus 1 integrates to minus u, and then we're going to add our constant, which our constant is going to be k for this question, just because it wants you to write as k. And then the final step is to put the u expressions back to x expressions by undoing the substitution, but that's going to look exactly as it does over here. Okay, so the final step is to rewrite as 4 ln 1 plus cos x, distributing the 4 minus 4 times another 1 plus cos x, and then plus k, and we're done. Right, so just pay attention to those little tips and tricks that I've employed as I go through that question. Hopefully they were helpful to you. I'm going to do one more important example, and that's going to tell you how to change bounds. And again, if you don't want to listen through it, you can just read through the Dr. Frost, and hopefully it's going to make sense to you on its own. So final example, I'm going to integrate from 0 to pi over 2 of cos x times the square root of 1 plus sin x dx. Now, there's no given substitution for this one, but you've got to have a nice educated guess. And the rule of thumb, as we said in a previous video, is to pick the thing that's the most awkward part of the expression, the thing that's going to cause the most difficulty. And I reckon that's going to be this bit in the square root here, 1 plus sin x. So that's the substitution I'm going to use. Okay, that's going to be the most useful one to use. And then, when I rewrite it in a moment, this is going to turn into square root of u, which is much easier to write as something that I can integrate. Okay, let's do the usual steps. Du by dx is cos x. Okay, and now because I've spotted cos x in my integrand up here, I'm not going to rearrange it fully. I'm going to write it as this. I'm going to write it as du equals cos x dx and leave it as that. And the reason for that is because all of this right-hand side appears in my question. It appears there and it appears there. So when I rewrite cos x dx in a moment, I can go straight to replacing it with du. And that saves me a cancelling out step. Okay, that's all changed. Cos x and dx is done, and this is going to turn into root of u, isn't it? Okay, before I write my integral in terms of u then, we need to look at this bit. So as it stands at the top, these are bounds on our integral that's in terms of x. So these are what x are equal to when I'm integrating these x's. If I want to integrate with respect to u, I've got to change the bounds into the equivalent value of u. So when x is pi over 2, that's the top bounds, u is given as 1 plus sin x, so that's 1 plus sine of pi over 2, which is 1 plus 1, which is 2. When x is 0 at the lower bound, we can similarly work out the value of u, that's 1 plus sine of 0. Sine of 0 is 0, so we get 1 for that. Okay, so now we've got to make sure that when we rewrite our integral, we're writing it in terms of u bounds. So I'm integrating from 1 to 2. Cos x dx, I know is going to turn into du. I'm going to put that at the end. And then that bit's done. And then root of 1 plus sin x is just root of u. Okay, much, much simpler. I can integrate that. I can write that as u to the half. And then use the power rule to integrate that. So that's going to turn into u to the 3 over 2. And then I'm going to divide by 3 over 2, which means timesing by 2/3. That's a constant, which I'm going to put to the outside. Okay, and then these are values of u, which I can sub into the box. So finally, we've got 2/3 on the outside. Sub in your values of u, that's going to be 2 to the 3 over 2 minus 1 to the 3 over 2. Okay. If you don't like having the 2/3 on the outside, you can easily keep it in. Doesn't matter which of those you do. It's going to end up the same over here. And then evaluate this. 2 to the 3 over 2 is going to be the square root of 2 cubed. And the square root of 2 cubed is going to be 2 times root 2. 1 to the power of 3 over 2 is still 1. And we're done. Okay, so hopefully that example was useful to you. The important bit is noticing that you have to change the bounds and then doing a bit of surd work at the end to tidy things up. Okay, right, best of luck with these questions. Hopefully you're doing all right with them. Again, if you need any help, please give me a shout. Thanks very much, Year 13. See you soon.